Welcome back, guys, as we continue our look at the series chapter. We begin by talking today about geometric progressions. Here's a geometric progression. 2, 4, 8, 16. Here's another example. 2, -6, 18, -54. And one final example. 1/4, 1/8, 1/16, 1/32. Now you can see in each of these cases, to get from one term to the other, we're multiplying by the same thing each time. So in this first one, I'm multiplying by 2 to get from 2 to 4, and I multiply by 2 to get from 4 to 8, and so on. In the second one, I'm multiplying each time by -3. That's why the sign changes each time. So -3 times 2 is -6, and then if I times again by -3, I get a +18, and so on. The last one, you can see that I'm timesing by each time 1/2. Okay, so those are what geometric progressions look like, and when we are giving the rule, we write the rule. The nth term is a, which is the first term of the series, or the progression, sorry, times the times r, where r is the common ratio between each term, times n to the power of n minus 1. So in this first example here, this 2, 4, 8 one, we would write it as 2 times, and r in this case is 2, to the power of n minus 1. So, for example, if we wanted to find the fourth term, we would go 2 times 2 to the power of 4 minus 1. And that would be 2 times 2 to the power of 3. And 2 to the power of 3 is 8. So that's 16, which is exactly right. So that's the nth term that we've got there. We can also talk about the sum of a progression. Now that is given here. The sum of the nth term is equal to a, the first term, times 1 minus r to the power of n, where r is the ratio between terms, all over 1 minus r. And you use that when you've got an r value between -1 and 1, but if you've got something that's greater than that, or less than -1, then you can use this. Okay. Right, that should be enough to get us started. Let's have a look at these examples here from number 1. Find which of the following series are geometric progressions, and if they are, write down the common ratio. Well, I'm going to look at 1a, and I see that the common ratio here, I'm just timesing it by 3 each time. 5 times 3 is 15, times 3 is 45, times 3 is 135. Now let's look at C. That's the only other one I'm going to look. Is it a geometric sequence? Well, how do I get from 1/2 to 1/3? Well, I would have to times 1/2 by 1 over 1.5, or like that. Okay, and that would give me 1 over 3. But then if I try 1/3 times by 1 over 1.5, that's going to get me 1 over 4.5. So there's no common ratio here. So that's not a geometric progression. All right, let's have a look at this number 2. The first and second terms of a geometric progression are 4 and 12 respectively, and we've got to find the sum of the first 10 terms. So here's our progression. It goes 4, 12. Now if it's geometric, then we can work out the ratio, or the r value, is obviously 3. Now to find the sum of the first 10 terms, sum 10, is going to equal, now we're going to use this over here, a, my a value is 4, times r, now my r value is 3, and I'm doing this to the power of 10. And then I'm going to subtract 1 from that, and this is going to be all over r, which is 3 minus 1. Now if we plop this in the old calculator, let's have a look what we get. So I'm going to have 4 bracket 3 to the power of 10, and I'm going to subtract 1 off of that. At the bottom I'm going to have 2. I'm getting 118,096. So my answer for this is 118096. Let's have a look at number 3. The third and fourth terms of a geometric progression are 5 and 20. So we don't know what first term, second term, but we do know third term, and we do know fourth term. Right, so we now know R, don't we? The common ratio must be times by -4. Right, so to go back this way, we must divide by -4. So this one must be -5 quarters. And if we divide by -4 again, we should have positive 5/16. Now you can do a check and go, well, what's 5/16 times -4? That gives me -5/4. I times it by -4. Yep, this is perfect. I'm doing good. Now, I found my first term. That's A. I found my common ratio, which is times 4, and I want to find my ninth term. So I'm going to use this formula here. My ninth term is going to be A R n minus 1, or in this case, 5/16 times -4. I'm going to chuck that in a bracket. And I'm going to go n minus 1. Now, what am I looking for? I'm looking for the ninth term, so n minus 1, 9 minus 1 is 8. Alright, now chuck this into your calculator. Okay, so it's going to be -4, put that to the power of 8. And I'm getting 20,480. 20,400. Whoops. 20,480. Alright. Okay guys, so we're going to carry on with a few more questions from the exercise. We're going to start off with number 5 over here. Okay, what have we got? We've got to find the 13th term of this geometric progression. So 1.1 goes to 1.21. Now, this looks very familiar to me. I'm timesing by oh dear, not that. I'm timesing by 1.1. Okay. And therefore, we can just check that. Does that give us 1.3? Yeah, perfect. Okay, it does. Okay, so it's 1.1. Yeah, and that does work for that. Okay, so we need to find the 13th term. Well, easy as pie. We know that the 13th term is going to be A R n minus 1, where A is 1.1. That's our first term. We're going to multiply that by our ratio, which is 1.1. We're going to put that times 13 to the 1.1 times 30, 1.1 to the power of 13 minus 1, which is to the power of 12. Now, when we do this, 1.1 times 1.1 to the power of 12, for this I'm getting 3.4522712114. So I'm just going to give mine to 3 sig figures. I'm going to go 3.45. Okay. Now let us move on to number 6. For number 6, we have to find the sum of to 11 terms of this geometric progression. Now let's have a look. What have we got here? 1 minus 1/4 and plus 1/8 minus 1/16. Now, since we're changing between negatives and positives, the ratio must be a negative number. And it looks to me like we're multiplying by minus 1/2 each time. Yes, it does. Okay, now if we want to find the sum, we've got to use this formula here. So I want sum 11, and I'm going to say that is equal to A, which is 1/2. Then I'm going to times that by 1 minus R. Now R is negative 1/2. And I've got to put that to the power of 11, I'm putting a big bracket around there, all over 1 minus, now what do we say r was? Minus a half, so minus 1/2. Now I'm just going to pop that into my calculator. You might like to try this too. Okay, for this answer I'm getting 683 over 2048. 683 over 2048 would be my answer for that one. Now my last one, this is a little bit more tricky. We're using a bit of algebra here. So we've got x plus 5, x and x minus 4 are 3 consecutive terms of a geometric progression. Find the value of x. Well, if they are consecutive terms of a geometric progression, we know that each time we're timesing by the same ratio to get to the next term, which means x plus 5 times r is equal to x, and in addition to, so therefore r is equal to x over x plus 5, and in addition to that we can, so that's 1, we can also say that x times r is equal to x minus 4. So therefore r in this case is equal to x minus 4 over x, which means that this term, this and this are the same. So we can just solve this equation. Now when I do this, x over x plus 5 is equal to x minus 4 over x. I'm going to get on, just by cross multiplying, I'll get x squared is equal to x squared plus x minus 20. So I've just gone that times that, and that times that. Okay, and if I simplify this, I'll get 0 equals x minus 20, so x is equal to 20. And that is the solution to that one. Well, I hope you can get on with this exercise by yourselves. Now have a try at some of them. If you do get stuck, of course, ask me, and I think it should be good.